kita akan sama-sama menyaksikan presentasi dari tim Climate Change Art Center yang terdiri atas Osri Talita, Gabriela, Danindra, Andrianwe, dan juga Alivia Nabila. For Climate Change Art Centers, time and place is yours.
Hi, good afternoon, everyone. This is Climate Change Art Center team. I am Fia, and this is my team partner, Danindra. And there is also Gabriela that is joining us virtually via Zoom. First of all, I would like to thank the Green Building Council Indonesia for making this event happen, and the jury, and also everyone that is participating in this event. So do you all know that we are having a serious climate change right now? With that in mind, Climate Change Art Center is specifically designed to mitigate climate crisis through its green and healthy design, along with the net zero carbon and net zero energy concept. Next slide. To achieve this ambitious goal, this art center is designed with meticulous details of passive and active design to drastically reduce its carbon footprint. This includes the responding tropical climate of the site, doing the mass study for the building, maximizing the local materials with low environmental impact like timber structure, and also the use of low energy building technologies. In terms of functionality, the building is made to be accessible and friendly for all of the public visitors, including the special needs one. This building is also designed to be adaptable for future needs as it generates more energy outputs than its own needs with the use of highly efficient solar panel on its main building roof and parking area or energy building, or we would like to call it our solar tree. This building is also aimed to be 100% naturally ventilated and mechanically ventilated. Low energy equipment are also deployed to ensure the building can optimize its low energy performance. Next slide. These are the diagrams that informs our conscious massing study of the building in response to the site analysis to reduce the energy needs of the building. So we start with a linear form that elongates from the west to the east as a response to the topography and shape of the site and also the land regulations. And then the respond wind directions from north and south. The linear form is divided into three massing that consists of local community space, performing art space, and also parking area, which then they are creating a void between each masses. Moving forward, we are also combining the local community space with the performing art space in a huge solar farm above, leaving the parking building to be the main source of solar energy for this building. The terraced form building and the natural light device is also chosen to maximize the natural lighting inside. And last, we are trying to incorporate lush greeneries alongside the building as an air filtration, and also we create a river naturalization as the landscape responding to the site condition next to the river. Next slide. So with net zero carbon emission in mind, the building's passive design is a critical element in the designing process of the building. That is why we also study the existing condition of Kota Baru Parahyangan, such as the existing temperatures, precipitation, and also the wind, which here we got the data from Meteo Blue website. Next slide. So as we can see in the screen, the average temperature in Kota Baru Parahyangan is about 26 degrees Celsius with the humidity of 77.7% and 3 meters per second for the average wind speed. So based on that data, we are aimed for the 100% naturally ventilated building and also trying to have an adaptive thermal comfort in this building, as the wind that come from the north and the south create a cross ventilation, and with the help of HVLS, the hot air in the building will go upwards as a stack effect and later will be released through the gap in the roof. Next slide.
From the context and social analysis, it is divine what kind of art center that we need to bring. We see that our building needs to spread the awareness of the climate crisis and the pandemic situation. Digital, visual, and performance art is very effective that we see into spreading this information. For the local committee, we provide the product design and textile art, as given the local craftsmanship is mainly stone product and textile. From the right picture, all these functions is shaped into a thin linear shape to ensure the effective passive design, 15 meters width to be exact. All the main activity, like performance art and the product design, is located at the main building on the left side of the picture. On the small building on the right side, it's to be called the Solar Tree building. It is a parking building covered with full solar panel on its facade. This building is connected by a long skywalk bridge that's strictly for pedestrians and bicycles. Next slide. As we can see, the building is facing the main road with the entrance and the drop-off at the center and the surface circulation at the secondary road. The perimeter is full of greeneries as a sound buffering and the air filtering. The spaces of the landscape is also provided jogging track and also the water features that contain the rainwater harvesting and the rainwater runoff from the site. On the left side of the landscape, we can see the amphitheater that facing the valley and riverbed. The amphitheater is designed to be flexible, so it can be used as a communal space for its local community. And also spreading around the site, as you can see, there is urban farming that is provided to be for the cafeteria of the main building and for local communities. Next. From the plan, we can see the spaces of the main activities is surrounded by natural ventilated corridors that act as a communal area too. With the width of the building is 15 meters and the corridor is minimal 3 meters. All the toilets, next slide. As you can see from ground floor to fourth floor, all the toilets is located at the west and east side of the building. That is our attempt to block the sun heat from the main activity inside the building. And at the bottom of the slides, as you can see, there's a rooftop that we provide 2 gardens. On the right garden is the communal garden, and for the left side is the garden for the textile. That garden is, we can harvest the greeneries for the product of the material for the textile industries. It is our attempt to minimize the chemical waste of the textile industries. Next. Okay. A few details from our buildings. The details of the corridor on the left provided greeneries for the sound bufferings. On the middle, there is a detail of the light pipe provided to be light pipe to be daylight to the classroom and the offices. And the details on the right is the 3 solar building for the solar panels. Next slide. Next. We try to implement as much as greenness as we can to the site for the sound buffering. And there's also a urban farm on the left side for the communities, and along that is a jogging track. Next slide. On the east side, we can see how the pedestrian skywalk connecting all the buildings, enabling people from west to east and east to west by foot. The main building is shaped narrowed downwards to maximize the heat shade into each floors, and the solar tree is shaped narrowed upwards to maximize the sunlight onto the solar panel installed around the solar tree building facade. Next slide. The sky high can be used strictly by pedestrians and bicycles. People can access this circulation to the second floor of the main building and the parking building right from the side. Next. The main atrium is a full open corridor and held by HVLS to circulate the cold air and the hot air at the building. Next slide. This is the gallery lobby. As you can see, the timber structure that we choose It significantly affect the aesthetic of the interior spaces as well as the exterior spaces. Next. The Mainshow is designed to be flexible. It can be closed performance with mechanical ventilation system, and it can be semi-outdoor performance with all the wall is open throughout the performance. Next. And the main corridor for the each floors is provided for the communal area spaces and provided too with the greeneries at the, as you can see at the right corner. Next.
Okay, hi everyone. These are the active systems that we use in the building to optimize the energy consumption because we aim for a naturally ventilated building with mechanical fan help. We use high volume, low speed fan to help to circulate the air inside the building. So you can see that there's two types of HVLC fan. We also use an energy saving artificial lightings and also energy efficient smart sensor throughout the buildings. Next slide, please. All glasses for windows and doors in the buildings will utilize the AGC Sunfort glasses to reduce the solar thermal radiation. By using this energy efficient Sunfort glass, the building can achieve a good score of 13.21 in its OTTV throughout reduced thermal radiation. From the daylight simulation by Dialux, it shows that 29% of the floor area in the building is covered by natural daylight of 300 lux or more. For area that is not covered by natural daylight, we'll be using energy efficient artificial lightings, and some of the classes and studio on level 4 will use light pipes and skylight to let the natural lights in. Next slide. Based on the building energy calculation methodology provided by the Green Building Council Indonesia, the total energy consumption of this art center is 1.3 million kilowatt hour per year. This building design achieved a significant 44% reduction of energy usage against the baseline. The passive design allows natural lighting to penetrate approximately 29% of the total area of the building mains area. Moreover, the most energy saving comes from the naturally ventilated strategies and also the use of any energy efficient high volume, low speed fan instead of aircon system. Next slide. Yeah. So this is the solar, the location of the solar power. The parking lot area or energy building, as we called it, with its solar tree installation and solar panel installed in the main building roof will generate around 2 million kilowatt hour of electricity at its peak capacity. This on-site energy generation will comfortably fulfill 100% of the building's annual energy consumption. In the future, when the need of parking lot is no longer a priority and public transportation is already more accessible on-site, the building mass can be altered for many alternative uses, including lodgings or offices, while still generating energy for the building. Next slide, please. More than 50% of the water needs in the building can be supplied from on-site rainwater harvesting, and almost 100%, or to be exact, 99% of the rainwater will be collected and be used for the building. The overflow rainwater that falls within the site area is going to be accommodated by small canals designed as a stormwater management. This is intended to reduce the overflow of rainwater to the city infrastructure so that the building will not negatively impact its surroundings in the future. Next slide, the last slide, please. We also already calculate the embedded carbon. This is the calculation. We managed to reduce the embedded carbon footprint of the building by using timber structure as the main materials of the building. The building is able to offset 1.9 million tons of embedded carbon through the recycle of CLT materials and reuse of the gula materials. Okay, next. Yeah, we hope this competition can trigger a better understanding of designing net zero energy building and highlight the urgency of climate crisis for all of us. Thank you for all your attention. Have a good afternoon.